So far this year in algebra, we've solved equations of all kinds. There's still a lot of kinds that we're going to solve in the future, but here we go. This first one here, this x plus 2 equals 6, what will we do to both sides? We'd subtract 2 from both sides. So we still do the same thing. On the next one, 5x is equal to 20. What would we do to both sides? We divide both sides by 5. X squared is equal to 4. We've just been doing that in this last unit. In order to solve that for x, we would take the square root of both sides. That's right. So, hang on. All right, so now, what are we going to do to solve the square root of x is equal to 4? We need to undo it somehow, and whatever we do, we're going to have to do it to the both sides. So what the method of our attack is going to be to square both sides, because the square root of x raised to the second power is x. So square both sides. All right, some examples, some simple examples here. We're going to solve each equation and check our solutions. So square both sides, and the square root of a squared is equal to 7 squared. Square root of a squared is a, and 7 squared is 49. When I check it, place an a in, I get the square root of 49 is equal to 7. 7 is equal to 7, and that checks. So 49 is our answer. For b, when I square both sides, so square both sides, that's going to give me c is equal to positive 16. Negative 4 times negative 4, positive 16. When I check it, I get the square root of 16 is equal to negative 4, and that gives me 4 is equal to negative 4, and that does not check. So 16, even though we got it for an answer, doesn't work. So the question, when squaring both sides, is the answer we get always a solution? That answer is no. So when squaring both sides, if an answer does not check, so we get it but it doesn't check, we call it an extraneous solution. Because these extraneous solutions do exist, we must always check our answers when squaring both sides of an equation. All right, so steps, just very simply, solving a radical equation. You're going to first isolate the radical on one side of the equal sign. Then you're going to square both sides, I'm going to underline the word sides, of the equation. Solve the resulting equation, and then check your answers and decide if one of them or both of them is extraneous. All right, so here we go. So we got this. We've got a radical because we have this radical. To undo it and get into that x and get the x out of the radical, we're going to square both sides. So I'm going to take 5x minus 1 is equal to 3, and I am going to square both sides of the equal sign. So it's as a big clump. So when I square a square root, whatever's on the inside of it comes out. So that leaves me with 5x minus 1, no radicals, is equal to 9. Then I'm going to solve this little equation, so plus 1 to both sides, so that gives me 5x is 10. Then I'm going to divide both sides by 5, and I get that x is equal to 2. I probably should have checked it yet. Should have circled it, because I still need to check. So let's check it to make sure that that 2 actually works. So I have the square root of 5 times 2, which is 10, minus 1 is equal to 3. So square root of 9 is 3. 3 is equal to 3, so that checks. And now I can circle my answer and say that 2 does indeed work and is a solution. B, when I do B, I'm going to need to do that step of isolate the radical. Here I have my radical it ends at the 3, so I want to get it alone. So to get it alone, I'm going to subtract 2 from both sides. So that leaves me with the square root of a minus 3, put the little end on it there, is equal to 5. Now I'm going to square both sides. So I'll take the left side, square it, the right side, square it. When I square my radical, the inside comes out. And then 5 squared is 25. Solve this little equation, so plus 3 on both sides. So I get a is equal to 28. So let's check it and see if it works. So check. I'm going to have the square root of 28 minus 3. And then outside of that, plus 2 is equal to 7. So the square root of 25 plus 2. So 5 plus 2 is equal to 7. And I can see that that checks. So that means that a equals 28 is a solution. Another one here, number C, letter C, going to square both sides. The radical is isolated, so I'm going to square both sides. So that's x squared is the square root, is equal to the square root of x plus 20, whole thing squared. So that gives me x squared. When I square my radical, that brings out the x plus 20. All right, so this one's a little different because it has x squared. If I have x squared, then it's a quadratic. And if I have a quadratic, in order to solve it, I need to get a 0 on one side, and then I'm going to factor it. So let's see, let's subtract. Subtract our x and subtract our 20. So we get x squared, subtract x, subtract 20 is equal to 0. Don't forget the 0 over there. Factor it, short AC. Two numbers that multiply to be negative 20 and add to be negative 1 are going to be negative 5 and plus 4. Negative 20 add to negative 1 is equal to 0. Take each little factor and set it equal to 0. And that means that add 5 to both sides. So x is 5, subtract 4 from both sides. X is negative 4. All right, so let's check them. So when I check, let's check x is 5. That is going to give me, going to the top right there, that is going to give me 5 is equal to the square root of 5 plus 20. So 5 is equal to the square root of 25. 5 is equal to 5, so that checks. And then I'm going to check out the negative 4, so I have x is equal to negative 4, so it's going to, again, up here, it's going to give me negative 4 is equal to the square root of negative 4 plus 20. So negative 4 is equal to the square root of 16. Negative 4 is equal to positive 4, and that does not check, so it is extraneous. That's an extraneous solution. So next, and the next group of problems will focus on squaring both, and I'm going to emphasize this, kind of capital here, sides of the equation. If a side has 2 terms, you will need to FOIL the side when squaring it. So either FOIL, double distribute, use your square, whatever you want to do. All right, so notice on example 3 how my left side over here has got 2 terms to it. So you've got 2 terms right here. So when I square it, I can't just square it and say x squared minus 4 squared. That doesn't work. I've got to square the entire side. So the whole thing as a unit is going to get squared. And then I'm going to square this. Now, the right side here, this whole thing is a radical, so it's like one single thing, and when it gets squared, it becomes just 2x minus 5, because the radical gets undone with the squaring. On the right side, though, I'm going to end up with x minus 4 times x minus 4, and that's going to be x squared minus 4x minus 4x, x minus 8x, and then plus 16 is equal to 2x minus 5. Then to solve it, because we have this x squared term right there, that tells me I need to bring everything over to one side. So I'm going to subtract my 2x and my 5 and add my 5, plus 5. And that's going to give me x squared minus 10x plus 21 is equal to, what's it equal to? 0. 3 terms, I'm going to use the AC method. 2 numbers that multiply to be 21, 7 and 3, and they're both going to be negative. That gives me a positive 21, adds to be negative 10. So x minus 7, x plus 3, set each factor, equal to 0, solve it. So x is 7, and x is 3. Check. Draw a little squiggly line here. So let's check it. And when I do check the x is 7, that's going to give me 7 minus 4 is equal to, I'm checking over here, is equal to the square root of 2 times 7, that's 14, minus 5. So 3 is equal to the square root of 9. 3 is equal to 3, and that checks. Then let's check the x is equal to 3. And we will get 3 minus 4 is equal to the square root of 2 times 3, that's 6, minus 5. So that's negative 1 is equal to the square root of 1. Negative 1 is equal to 1. And that does not check. So x equals 3 is said to be extraneous. Now you'll need to always check it. Sometimes they both work. Sometimes, like in our 2 examples here, only one of them works. Sometimes neither one of them works. So you want to always check. One last example. On this one, notice that we need to isolate the radical. Here you can see where the radical is, and it ends right here. So I'm going to subtract the x from both sides. And that's going to give me 5 subtract x is equal to the square root of 18 minus 2x. I'm going to square both sides, so I'll rewrite it. Square both sides, and again, you're squaring, remember, the entire left side of the equal as a group and the entire right side. So on the left side, I'm going to FOIL it, and that's going to give me 25 minus 5x minus 5x is minus 10x, and then plus x squared is equal to, and then over here, squaring the square root gives us 18 minus 2x. Again, we have a quadratic. Let's see the x squared. So I'm going to subtract the 18 from both sides, and I'm going to add the 2x to both sides. And I'm going to put x squared minus 8x plus 7 is equal to 0. Factor with the AC. So I'm going to have x for 7, that's going to be a 1 and a 7, minus 1 minus 7. So that's going to give me a positive 7, adds to be negative 8. Set each factor equal to 0. And then solve. So plus 1, get x is 1 and x is 7. Check it. And when I check the 1, so we'll check x is equal to 1, that is going to give me, and again, I'm checking it, let's see, go back all the way up. I'm going to check it up here to the original, in case I made a mistake somewhere. So that's going to be 5 is equal to the square root of 18 minus 2 times 1, so minus 2, and then outside of the radical plus 1. So that's 5 is equal to the square root of 16 plus 1. 5 is equal to 4 plus 1. 5 is equal to 5, and so x equal 1, checks. And then let's check the other answer, which was 7. So that will give me 5 is equal to the square root of 18 minus 2 times 7, that's 14 in that radical, and then plus 7 outside. So that's 5 is equal to the square root of 4 plus 7. 5 is equal to 2 plus 7. 5 is equal to 9. Not true. So x is equal to 7, we'd say is extraneous. All right. So take a look at that and be ready to come back next class and work some problems. Have a good weekend.